Hello everyone, good morning and welcome. I'm Purna, Associate Data Engineer at Boolean Data Systems. Boolean Data Systems is a selective partner of the Snowflake Data Cloud, and we mainly focus on building customized industry-specific data and AI solutions that solve real business problems. Today, we have Raju with us, and he'll be walking us through how we can forecast electricity energy demand using data and machine learning. So yeah, let's get started.
Hello, Purna.
Hi Raju. To set some context, let's start with the basics. Can you explain what energy demand forecasting actually means and why it's such an important problem to solve?
Yeah, sure. So, at a very simple level, energy demand forecasting is about predicting how much electricity people will need in the future, maybe for the next few hours, days, or even months. This is really important because electricity can be stored easily at a large scale. It has to be generated and supplied almost in real time. If demand is underestimated, utilities can face power shortages or even blackouts. And if demand is overestimated, they end up generating extra power, which increases costs. With things like renewable energy, electric vehicles, and changing usage patterns, demand has become more unpredictable. So, accurate forecasting is important now than ever.
Right, that makes sense. So, what happens when forecasting isn't accurate? How does that affect the utilities and customers?
Yeah, from a customer's point of view, the impact is very simple. You might see power outages or unstable supply, especially during peak hours. Electricity costs can also go up because utilities may need to rely on expensive power backup sources. Over time, this affects customers' trust since frequent disruptions reduce confidence in the provider. Operationally as well, it makes grid management more complex and stressful for utility teams.
Okay, before modern solutions like this, how are companies usually handling demand forecasting?
Earlier, most organizations depend on fairly basic approaches. They use historical averages to estimate future demand. Some use simple statistical or rule-based models which worked only when conditions were stable, and often experts manually adjusted forecasts based on experience. These methods work to some extent, but they don't handle today's fast-changing and dynamic consumption patterns very well.
That gives a good picture. Before we get into the predictions, can you quickly explain the dataset you are using?
Yeah, wait. Can you see my screen?
Yes, Raju, your screen is visible.
Yeah, this is my dataset table. If you look at the dataset preview, each row includes both time-related and environmental details. We have things like timestamp and hour to capture hourly demand patterns. Day of the week, month, and year help capture weekly and seasonal trends. There are also temperature and humidity, which play a big role in electricity usage. All these features together give the model enough context to learn realistic data demand patterns.
Okay, now let's talk about the solution. Can you show me the model and explain the model at a high level?
Yeah. At a high level, the model is trained on historical electricity and weekly trends like daily usage peaks, weekly trends, seasonal behavior. Using these patterns, it predicts future electricity demand. To make this easy to use, we built a Streamlit application on top of the model so users can interact without worrying about the ML details. Yeah.
Okay, coming to the UI, it looks very simple and clean. What inputs does the user provide?
Yeah, we kept it intentionally simple. The user provides the date and time for when the forecast should start. They also enter temperature and humidity values since weather strongly affects energy usage. And finally, forecast horizon, for example, predicting demand for the next 24 hours so the UI stays easy to but still captures all important factors.
Okay, I also noticed a historical summary section below the inputs. What's the purpose of that?
Yeah, the section gives users some context before they look at the forecast. It shows average historical demand so users know what normal consumptions look like. It also highlights peak demand values and total number of records used for training. This helps user trust and better understand the forecast results. Yeah, when I predict the model based on the input parameters, takes some time to load the predictions. Yeah, this is the output of the forecast model. Here it predicted
Okay.
the average demand as 4,000 units per kilowatt, and also estimated the peak demand in very uncertain situations. This is all about the model UI.
Okay. So, from a technical point of view, how does machine learning improve forecasting compared to traditional methods?
Yeah, so machine learning adds a lot of flexibility. It automatically learns recurring patterns like daily peaks and seasonal cycles. It can also detect changes or anomalies such as sudden spikes in demand, and as new data comes in, the model keeps improving over time. This makes ML based forecasting much more reliable than fixed rule or manual approaches.
Okay. So, how can organizations integrate this solution with their existing systems?
Yeah, integration is pretty straightforward. Forecast outputs can be stored in the platforms like Snowflake, shared through APIs, or connected to energy management system. You can also build dashboards for planning and operations teams to monitor trends and take actions.
Okay. Finally, from a business perspective, what kind of benefits does this solution provide?
Yeah, from a business standpoint, there are several clear benefits. Organizations can reduce operational costs through better planning. Grid reliability improves with fewer outages and better handling of peak demand. It also supports renewable energy integration by helping balance supply and demand. Overall, it leads to better decision making and improved customer satisfaction.
Okay, thanks, Raju. That was a really nice walkthrough. It clearly shows how data, machine learning, and a simple UI can come together to solve a real world problem. That brings us to the end of today's webinar. Thank you everyone for joining, and we hope you found this useful.